Hello everyone. We will be discussing in this video are as follows. First, Grashof criteria. Second, velocity analysis. Third, acceleration analysis. Fourth, synthesis of the mechanism. Fifth, simulation of the mechanism. Sixth, graphical analysis. Seventh, force analysis. So coming the Grashof criteria states that in a 4-bar mechanism, if the sum of the shortest and the longest link is less than or equal to the sum of other two links, then the shortest link will rotate completely with respect to all other links. In this figure shown, O2A is the crank, which is the shortest link, and link O4C is the coupler, and AC is the supporting link. As this mechanism satisfies the Grashof criteria, link O2A rotates completely about all other links. Then I will for this linkage two-way Grashof linkage shortest link plus longest longest link less than equal to P plus Q. If this condition is satisfied, then the shortest link then O2A the shortest link can rotate 360 degree with respect to either long linkage or the linkage Q.
Moving on to velocity analysis. Let us consider the windshield wiper mechanism that was given in tutorial 2, problem number 6. And let us consider the mechanism in an intermediate configuration that is not at the dead center configurations. Now, if you observe in triangle O2AC, if we apply sine rule, we get this particular relation. Before going there, let us just analyze the linkage. Let us consider the link O2A to be link number 2 and link AB to be link number 3 and link BO4 to be link number 4. Now, if we find if we try and find the IC of link number 2 and link number 4, we will find that the IC of those two links lies on the link number 3 at point C, as we can see here. So now coming back, if we consider triangles O2AC and triangle O4BC and we apply sine rule in both the triangles, we get the following relations that O2C is equal to L2 sine theta 2 minus theta 3 by sine theta 3 and O4C equal to L4 sine theta 4 minus theta 3 by sine theta 3. Now since this point C is the IC of link 2 and link 4, we can write this relation that the angular velocity of link 2 into O2C will be O4C into the angular velocity of link 4, which will give us the relation between the angular velocities of link 4 and link 2, which comes out to be theta 4 dot is equal to minus of L2 sine theta 2 minus theta 3 divided by L4 sine theta 4 minus theta 3 into theta 2 dot. The minus sign indicates that the directions of rotation of link 2 and link 4 are not same but rather opposite. So at this quantity, the L2 sine theta 2 minus theta 3 by L4 sine theta 4 minus theta 3 is also called as a Jacobian. Now, since we finished velocity analysis, moving on to acceleration analysis. From the velocity analysis, we have obtained a relation that theta 4 dot is equal to j times theta 2 dot, where j is the Jacobian. And we can also write this as theta 2 dot equal to j inverse into theta 4 dot, where j inverse is called the inverse of the Jacobian. Now, to obtain acceleration, we know that we have to differentiate velocities. So, differentiating this equation with respect to time, we get theta 4 double dot is j times theta 2 dot plus theta 4 double dot is j dot into theta 2 dot plus j into theta 2 double dot. And now, if we simplify this further, we will finally get the relation between, we will finally get the accelerations. We just take j equal to L2 sine theta 2 minus theta 3 by L4 sine theta 4 minus theta 3, and we expand it, and then we differentiate it with respect to theta 2 and submit it back in the equation, which gives us a relation between theta 4 double dot and theta 2 double dot. This brings us to the end of acceleration analysis. Now, moving on to the main part, synthesis of the mechanism. The windshield wiper mechanism is a 4-hour mechanism in which a crank, which is often the shortest link, performs a complete rotation, which results in the rocking of the rocker. The rocker is the wiper in this mechanism, which means that from this we can conclude that the mechanism follows the Grashof criteria. Also, we have to synthesize a wiper mechanism so that it does not exhibit quick return effect as given in the problem statement, which means that the time taken for the forward stroke of the wiper is same as the time taken for the backward stroke of the cycle of the wiper. So we follow these given conditions and we are going to now synthesize a wiper mechanism. The first page shows the velocity analysis, and from there we try to find out the angles of rotation of the crank and the rocker, and we find the difference between the angles, and we take the ratio of the forward stroke to the backward stroke, which is called time ratio, and we equate it to 1, which gives us this which gives us the angle rotated by the crank. And further simplifying these equations, we finally get a relation between the lengths of the links, which is given as L3 square plus L4 square is equal to L1 square plus L2 square. And using this relation, we can now synthesize the windshield wiper mechanism.
And I will be explaining our simulation in MATLAB. So this is the code we have written for the simulation, and here it is being simulated in MATLAB. So we have specified the length of the different bars. We have some friction force also. Then we are simulating at intervals of 0.05 seconds till 7 seconds. We have an angular speed of 2. We know that points A and D are fixed. Using that, we can find the other points. We know that theta 2 is given here and theta 4 is also given. We have found the velocities using the differentiation function in MATLAB itself. This is the loop. This is the loop we are running at an intervals of 0.05 seconds. After each loop, we are deleting the elements so that but we are not deleting the wiper so that we get a shaded area as seen in the figure. So this is the end of our simulation. We thank Professor Anirudh Das Gupta to give us this opportunity to do this project.